This wouldn't have been possible without the help of several people listed here. They were integral to making this happen, and I want to acknowledge their support and contributions. Okay, so as part of this, we received a series of questions from both folks in Region 5 and 6, and one of them had to deal with the foundation of the aquatic conservation strategy, which was developed as part of the Northwest Forest Plan. And in reviewing the literature, we would say that foundation is still solid. And you have to make sure we understand what was going on here. We're focused on ecological processes. Now, this was a real shift at the time, moving away from looking at individual components to a focus on processes. And the literature is moving, in the scientific literature, it's containing more and more about aquatic systems and dynamics. And so we're in an interesting transition period here, where we viewed aquatic ecosystems as relatively stable, having an ideal set of conditions usually associated with old growth, to ones that are more dynamic and variable. The other aspect of the aquatic conservation plan was looking large. And in reviewing the literature and what was done in the 23 years since the plans were changed, it was interesting looking at attempts to integrate the terrestrial and the aquatic and think about large scale. We could come up with one really good example. It was the Augusta Creek work that was done up on the Upper Mackenzie on the Willamette National Forest, where they really tried to integrate the management of terrestrial and aquatic ecosystems. I think it was very, very insightful and very forward-looking in terms of its approach, in terms of integrating those. Unfortunately, it never happened. Nothing came to fruition because of concern that some large trees were going to be cut. And that presented some sort of social political roadblock. But certainly in moving forward, this is the type of thing we should look to for some guidance in terms of how we would want to move it, how we want to think about larger scales. The other aspect of this is what do we really expect at larger scales? The aquatic folks are really good at thinking about small scales and what, a reach, maybe a habitat unit. But when we move to larger scales, the rules change. And this is just some examples of what happens here. So this is dealing with fish population, but we can make the analogy with habitat. At the small scale, there's a lot of variability over time in terms of fish numbers or conditions. And we're just delving into some work now looking at variability in habitat conditions annually in systems. And it would look very much like this, okay? When we talk about what we're trying to do and manage at larger scales, though, we get a different pattern. And we haven't been very good at articulating that. We've sort of taken the rules that we're comfortable with at the small scale and applied them to larger scales. And that's not how the world works. And so I think one challenge in moving forward is articulating and identifying what we expect to happen as we talk about these different scales, so that the managers understand, the public understand what's going on. When we start looking at the riparian reserve network, and I'll just throw a commentary in here, we never should have used that word reserve. If we made one mistake in the Pink Tower, it was using the term reserve in terms of designating a management area. That it was interpreted to be a reserve with pretty much eliminated all activities, and that was never the intention. But nonetheless, these were defined based on these curves that were based on professional judgment at the time. A review of the 23 years since then suggests that these curves have held up quite well. The one change that we might want, that we would suggest could be made, is in terms of the riparian reserve width on these fish-bearing streams, which is 2 site potential tree heights. The literature would suggest that that second tree height, which was designated based on the need to maintain microclimatic integrity in the riparian reserve, is not justifiable from a scientific perspective. We could find evidence that in the work that suggested that the smaller riparian reserves maintain the microclimatic conditions. There were some suggestions about that the second tree height was needed for movement of organisms across the landscape. we could find no support for that in the literature. There may be things in there that we missed, but you know, we looked pretty thoroughly. And so one of the suggestions would be that that second tree height is not justifiable from a scientific perspective. What do we know about the fish-bearing stream portion of the network? Remember, this is, we said the second tree height potential is not supported by the recent science, but there's some suggestions for active management in here, and for a couple of reasons. One is going to be getting hardwood back in these systems. There's some evidence in the literature suggests that the hardwood component is being lost in many of these systems. Ecologically, these are really important, if nothing else, just as the fuel base for the food webs in these systems. The other one is the large trees, these key pieces, as we call them. Turned out that some recent work at OSU has shown that these pieces originate from really close to the channel, and they develop under really low initial stocking densities. And so these really big trees that we have, and we're trying to get back, we're going to have to do things differently if we want to see them on the landscape. We're going to have to do some thinning, probably some pretty intensive thinnings in places near the channel to get these big trees to develop for future recruitment. There's really strong evidence to support how that could be done. This has generally been, if we think about it, we have these no-touch zones. You know, we want to stay 100 feet or 150 feet away from the channel without any activities, under the guise of protecting some processes, but in doing so, we may be compromising others. So we need to think about what the trade-offs are before we just pronounce we're not going to do something. The non-fish bearing streams, which comprise, prior to the Northwest Forest Plan, received hardly any attention. There's been a wealth of research done on these systems, something like over 2,000 published publications on headwater streams since the Northwest Forest Plan was developed. They're ecologically important. Every time we look, they turned out that these streams, we find new things. They're sources of wood, they're sources of sediment, places of nutrient storage, high sites for biodiversity, a number of different things. But again, we may need to do more active management in these, and particularly getting hardwood back into the mix here is going to be crucial, as well as getting large trees along these runout tracks. And it turns out that wood from these headwater streams and many of our aquatic ecosystems originate not from the stream adjacent riparian zone, but from these upslope sources. Okay, as much as 60% or more of the volume of wood we see in many streams come from landslide delivered wood from these headwater streams. And we now have enough knowledge that we know we can identify which parts of the network are most likely to be delivering wood during landslide events. And we should be managed, you know, one of the things would be an option to manage silviculturally for big trees along these particular parts of the network to grow these big trees for delivery. The other thing that happens when you have these large trees in your landslide, the landslide behaves completely differently. It moves much slower down the slope, and when it hits the valley bottom, it tends to set up. It's not this slurry that just runs out. So we, you know, think about managing the quality of the landslide is what we're really suggesting here. These are also a number, we talked about a number of different things going on here in these systems in terms of ecological functions, and they only happen if we can have this type of sequence happening. Oftentimes what happens, we have a landslide and we evacuate the channel, and then there's nothing there to restart this filling process, this successional track, if you will. One of the things that could be thought about is focusing restoration efforts in terms of dropping big trees into these channels to begin that filling process again. That does two things: storing sediment on the landscape. It's also jump-starting these ecological processes, the storage and the processing of nutrients, creating habitat for a number of different organisms, including amphibians and aquatic invertebrates. These places become key sources of food for the fish-bearing stream. So 70 to 80% of our network is right here, and we hardly pay any attention to it. It's something that's worth doing moving forward. In terms of management, we've seen pretty much a one-size-fits-all approach to managing aquatic ecosystems where we set a particular zone. There's some new information available to suggest that we could maybe try some other ideas in terms of managing on what we call the ecological context. You look for places that are more important ecologically than others, and you do one thing versus another. I'll just give you an example of how important this could be. We did this. We did some work for Senator Wyden with the BLM lands in Western Oregon, and we reduced, by using this system, we reduced the size of the riparian areas in watershed by about 7%, and it increased the available timber base for harvest by 50%. Because and the matrix is so small, adding things to it can really greatly increase some other benefits. So there's other ways of moving away from this one-size-fits-all approach. One of the big issues with the forest has been water contribution and the contribution to the amount of water coming off of these federal lands for other uses. We looked across the region, and it's highly variable. And there's some really nice information that is available, but in some cases, a really large amount of water is coming from the federal land. In other cases, it's not. And so, but there's ways of looking at this and finding out in greater detail. Key watershed, which were one of the cornerstones of the aquatic conservation strategy, okay? In the 10 and the 15-year assessment, these systems showed the greatest improvements. In the 20-year report, there was the same level of improvement in these watersheds as the non-key watershed. Now we'll talk about maybe some of the reasons for that. But one of the things we should think about is these key watersheds are a foundation of the aquatic conservation strategy. And the other thing we know about these is that they've got less capacity to support the recovery of ESA-listed fish than we originally assumed. One of the assumptions that we made when we were in the Pink Tower was whatever we did on federal land was going to be sufficient to recover. At the time, you got to remember, there's only 3 fish species listed. There's something like 30 units now listed. But the idea was that the federal land would bear the disproportionate amount of responsibility for the listings of those fish or the recovery of the fish. The federal lands simply don't have that capacity. They're important, but they alone cannot do it. And the key watersheds are a good example here. One of the things we learned with the key watershed is, what we've learned is old growth and fish don't necessarily go together. There's been the assumption that the best fish habitat, the best aquatic conditions are associated with old growth forest. Well, if you look at the literature suggesting that if you want the most diverse fish communities and some of the more productive fish communities, are not associated with old growth, they're associated with earlier successional stages. So one of the things we would think to do is that the key watershed were tightly integrated with the late successional reserves. And so reassessment of the key watershed, we might not make that coupling quite as tight. And just to show, one of the things we're going to have to do in terms of thinking about the capacity of the federal lands and the contributions is going to be highly variable. This is just some analysis we did, again, for Senator Wyden, showing that the potential contribution, the most productive habitats for fish are not always found on the federal land. And it's highly variable across watersheds, and that what we need to do is really pointing to the direction for more integrating. We're gonna have to collaborate more closely with our non-federal partners to really make contribution to the recovery of these fish. And again, I want to emphasize, this is not to say that the federal lands are not important. It's simply to say that they themselves cannot do as much as we originally expected. Climate change. As mentioned this morning, this wasn't something that was particularly on our mind when we were in the Pink Tower 24 years ago or 25 years ago, whatever it was over here. But now it is, okay? And one of the things we know about climate change, and I think Matt and Tom started pointing this out, is the real effect of climate change. We've got to really get down and look at it on the ground and see what it really means to the local areas. And So this is just some examples of some work looking at the northwest projections. You know, normally what we see are projections from up here. And we think, oh Lord, there's a lot, you know, that doesn't look very helpful. But we can, if we start projecting things down, we get much different pictures. And one of the things we can do then is to look at where we can really make a difference, taking this information. There's been a lot of work suggesting that if we can restore riparian areas along many streams, we can potentially offset and maybe even reduce water temperatures in the future, as opposed to seeing them rise. And what you're seeing here is an analysis, the red areas, whoops. The red areas are where the riparian zones are going to make a difference with water temperature. And again, what we're going to see is what we do, where we go to do something is every bit as important as what we do. And so we've got to be, you know, use these new tools and thinking to help us move forward. Okay, one of the things we need to recognize, and this is something Tom pushed on, is the past and the present is not going to be the future. We're going to have to, you know, we got to start thinking differently about how these systems are going to respond over time into different things. And so that's going to be a real challenge about how we do that. The other thing with regard to the aquatic community, there's going to be winners and losers. And we need to acknowledge that, recognize that. And, you know, some species are going to have a life history strategies that are going to allow them to persist in the future, in the future environment. The others maybe we're going to struggle. And this is, you know, this is beyond what we can control, but we need to start thinking about, you know, where we're going to see sort of potential big responses versus things we may, you know, a negative side of things. In order to do this, I think we're going to have to make a mind shift in terms of really what we're managing the aquatic ecosystem for. Right now, it's all for numbers. You know, we want to get more fish back when we do restoration work or under the guise of other management. The real challenge should be, how do we get a greater array of life history types back or maintained on the landscape? So creating a diverse landscape that allows for this expression of life history types, as opposed to a single focus on numbers, should be something that we think about moving forward. And some really interesting, this is why I think, you know, the call for greater collaboration is going to be really important. It's going to happen right here. Okay, monitoring. The 10 and the 15-year reports were, and comparing the results to the 20-year reports were really difficult because there was a shift in the methodology and some other things. This is something that we need to work through is how to move forward with monitoring efforts. Okay. So just to summarize real quickly, the aquatic systems in the Northwest Forest Plan area are likely improving, but slowly. And this is what we predicted 25 years ago. It was going to take time for things to happen. They weren't changed overnight, and they're not going to necessarily go back or improve in a thing. So patience is going to be key here. The tenets and the framework of the ACS are sound. I think we can look in the literature, and it would really support that. As I said, we're in a transition period about how we view aquatic ecosystems, from one that's relatively stable and have an ideal set of conditions over time, to a more dynamic view. Okay, so we're in this transition. The regulatory and side is still sort of stuck on that stable type of situation, and so there's going to be some resistance in terms of moving forward. But I think it's going to be important that we start to articulate how we think the systems work. The opportunities exist for implementing the goals of the ACS, but we can do it differently. You know, there was a lot of flexibility was built into. We thought we built a lot of flexibility into the ACS and how it could be implemented with watershed analysis and other things. Unfortunately, that hasn't happened as far as we can tell. And it's something that, you know, before you throw the baby out, you know, look at it, because there's a lot of flexibility about how you can meet these goals there. one challenge is going to be, we got to think about either we go big or go home. I mean, the 2012 challenge rule is challenging us to do this. And it's really going to be incumbent, I think, in a real challenge for the aquatic component to do this, because we haven't really thought big in the past. We think big because we think about a small piece of ground and we assume we can just extrapolate up. Well, that's not how the world works. It's very clear in the science. So we're going to have to dig deep here and really examine the very tenets that we use to manage the system, and then build from there to get to how we're supposed to think big. We're going to need active management and riparian reserves in some situation. I mean, we can identify where those are going to be, but this idea of a hands-off approach, I think we've really got a challenge. We tried to do some, tried to get an estimate of how much of the riparian reserve in the Northwest Forest Plan area had active management in it. Unfortunately, the records are pretty poor about it being able to do that. Our best guess is 3 to 4% of the riparian reserve in the past 24 years has received active management. Now that's not very much, you know, when you think about the total area. And the area that, like on the slide that Peter showed, which was, you know, the number of acres, that's only outside after you take off the congressional reserves and the LSRs and everything else. So there's a lot more riparian reserve out there than is acknowledged in those figures. And we've only touched a small part of it. And, you know, a large part of this is going to need some form of active management. We need to, you know, re-examine the ARAMS process because we got this disconnect between the two processes. That's something that's ongoing. There's going to be potential options for meeting the challenges of climate change. Climate change does not necessarily have to be as overwhelming as it appears. I think that if we step back, start to look at really how it's going to express itself on a local level, use some of the analytical tools that we have, we're going to have some real options for moving forward and meeting those challenges.